Okay, we have here today another integral from the Swinbee 2019. This one's problem 11. We have the integral from 0 to 1 of 1 minus x over 1 plus x all squared dx. Okay, to get started with this, what I'm thinking is this is kind of close to having 1 plus x. If we had 1 plus x, we could do some cancellation. But what we can do is just kind of manipulate this numerator in order to set this up. So what I can do is, if I bring a minus out front, then I can change the sign here and write this as x minus 1. For x minus 1, what I can do is I can just kind of manipulate this and write this as, forcing this x plus 1 that I want, I can write x minus 1 as x plus 1 minus 2, and that's going to allow me to split this into two integrals. So for the first one, we'll still have the minus sign out front. We'll just use this first piece, and we'll write this as x plus 1. I'll change the order here just to make it clear. So we'll write it as x plus 1 squared dx. For the second one, we'll use this minus 2, distributing minus to minus 2. That's going to give me a plus 2 here. Then we'll have the same bounds that we're bringing over, 0 to 1, and then I'm clearly out of space. Okay, so in the second integral, we're just going to have this same denominator, but we just have the plus 2, and this is just like a 1 here, so this is going to become 1 plus x all squared. But then here's the cancellation we want right here. We cancel one of these with one of these. So now this here becomes an easy integral, because this is just going to be like 1 over x plus 1. So we can just do this one really quick. Integral of this is going to be natural log absolute value x plus 1 evaluated from 0 to 1. Now here on the second one, we don't really need to use substitution, but I think I'm just going to do it just to make it clear, because when you'll see what's going to happen is the derivative when we do our use substitution is just going to be dx. But let's just do it anyway to just be clear about it. So I'm going to call my u equal to 1 plus x. We'll take a derivative. Derivative of this is just dx. So then updating this, updating our bounds. If we put a 1 in here, we have a 2. Put a 0 in here, we have a 1. Then our dx becomes du, and then we're going to have u squared here, but I'm going to write it as u minus 2 to put it in the numerator, because we're going to use power rule on that. But then in the integral, this is just going to be minus 1 over u. So putting this together, let's see, this one, we bring this down, this is going to become minus 2 over u, and we're going to need to evaluate this from 1 to 2. And then we still have this other piece to evaluate, natural log x plus 1, evaluated from 0 to 1. And we'll just go ahead and evaluate. So first here, plugging a 1 in here, this is just going to give me natural log of 2. Of course, I'm going to drop the absolute value on that because it's just a positive number. Then plugging in 0 here, we're going to get natural log of 1, but that's just 0, so we'll leave that off. Then we'll come over here and we'll evaluate this. Plugging in 2, we're going to have 1 for our first term. Plugging in 1 here, we're going to have just 2. But now this here is minus 1 times minus is plus 1. So for my final solution of this, we just get 1 minus natural log of 2, and that's it. Okay, there you have it, a quick integral from Swinbee 2019. Thanks everyone for watching. Have a good day.